Good morning, everybody. Welcome to day 4 of reInvent. I honestly don't know how many days we've been here anyway. Thank you for honoring us with your presence and not going to the keynote somewhere else. We're really, really honored. My name is Mesh Saido-Casing. I'm a developer advocate with the ECS service team. We're going to be talking a little bit about today about Amazon ECS, and I'd like to introduce my co-speaker.
Hi everyone, my name is Malcolm Featley. I'm one of the senior principal engineers from the Container and Serverless org.
So this is CON401, deep dive into Amazon ECS resiliency and availability. The session is being recorded. The slides will be available after the event. So if you want to take pictures, you're more than welcome. If you don't want to, you can get the actual screenshots because it's going to be a good, decent amount of diagrams. It's going to be a deep dive session. We're assuming that you understand what AWS Cloud is, you understand what Docker is, you understand what a container is, and hopefully you're not new to ECS. So let's go over our agenda for today. So there are probably, maybe, hopefully, not very many of you who don't know what Amazon ECS is. So we're going to have a very, very small introduction, one slide of what Amazon ECS is, a few things about our service. Then afterwards, I'm going to hand it over to Malcolm about how we build our services for excuse me, for availability and resilience, what that actually means to us as an Amazon service team. Some concepts about architectural availability, resilience, and how we continuously improve. This is how we make our service what it is that allows you to deploy your applications in a safe, simple, and reliable way. So Amazon ECS is a native container services which runs on the AWS Cloud. If you pretty much know how to use AWS, EC2, whatever else, you'll probably know how to use the same thing. The same way you provision an Amazon EC2 instance, you can also provision a container on Amazon ECS. You have the options of running these containers in a number of locations, in the AWS regions, in AWS-supported hardware, which is located outside of the region, for example, on AWS Outposts, Wavelength, or Local Zone. You have the option of running not only on EC2, but also Fargate. Fargate is a managed managed serverless container compute engine, which allows you to deploy the container and not have to worry about what instances are running underneath. And the last option, of course, is with ECS Anywhere, which allows you to provision the same workloads in the same way on premises in your data center if you have these requirements. On supported software, we don't really care about the hardware, pretty much. But it doesn't make a difference if it's running on one vendor or another vendor hardware. As long as the supported operating system is supported, you can run your container in the same way, connected to the region, and manage all your workloads as you do. Amazon ECS is a service which is pretty, I would say, integral to how we operate with inside Amazon and AWS itself. We launch over 2.25 billion tasks every single week across all of our regions. That's a huge amount of traffic and API calls. We handle more than tens of thousands of API requests per second, every single second, 24 hours a day, across all of the regions. We are located and deployed as a service, 32 different AWS regions, 6 different continents. And the interesting thing is that 65% of all new customers to AWS will be using ECS. Because of its simplicity, the way that they're currently used to using, and they don't have to worry about managing underlying infrastructure in any kind of way. Our customers love ECS from all different segments, from whatever kind of vertical you may be, small companies, large companies, Fortune, some number, whatever it may be. Everybody uses ECS in some kind of way, but it's not only external customers. Amazon ECS is also an integral part of how we build services internally in our company. A lot of the services that you might recognize on the screen, SageMaker, Lex, Poly, AWS Batch, all of these things are utilizing the resources or the service of ECS underneath the hub and building their service, which they provide to you to use any of these services here on screen and others as well, using Amazon ECS for the same reasons as I said before, the simplicity, the reliability, and the security of ECS. So I'm going to hand it over to Malcolm, and he's going to go into more about the architectural resiliency and availability.
Hey everyone, I just wanted to add my thanks to you all coming out. Really appreciate it. So before we dive into talking specifically about how we build ECS for availability, to be highly available and highly resilient, I thought it might be useful for us to talk a little bit about some of the tenets, the design principles that we use in order to make sure that we're engineering our services in order to achieve those outcomes. And at the same time, I wanted to introduce you to some of the foundational building blocks that AWS delivers that we build on top of, that you can also build on top of, that form sort of some of the foundations that we use in order to make sure that our services are highly available. So to start off with, our CTO, Dr. Werner Vogels, has often been quoted as saying that in order to build systems that are resilient, you need to embrace failure as a natural occurrence. There's another person out there who is equally infamous, Mr. Murphy. So Murphy's law says that anything that can go wrong will go wrong. And certainly our experience has been that this generally tends to be true. And in fact, he adds to that at the most inopportune time. And so really, the key takeaways to that are that in order for us to be able to make sure that we're building services that are highly resilient and highly available, we have to embrace the notion of failure as part of the design or the architecture for the service itself. And then, in addition to that, we also want to make sure that we're normalizing the operation of the service such that we're we're normalizing the notion of failure as part of the operation of the service. So we want to design for the notion of failure, and we want to normalize the operation of the service such that when failure does occur, it's just part of our normal operating procedure. Now, I'm going to talk a lot about availability and a lot about resilience, and I thought it might be useful for us to quickly start by defining what we mean by those terms in the context of this conversation. Availability is, the way we're talking about it, is a probability. It's a probability metric. In effect, if you have a web service that is serving 100 requests and it was able to usefully serve 100 of those requests, then it is 100% available. So availability is the ability for the service to be able to do useful work when needed. If, in this particular case, the service only served 99 of those 100 requests usefully, then the service is 99% available. And our goal is obviously to reach that nirvana of 100% availability. We want to be able to make sure that our service is always available to do useful work. Resilience is a key attribute that feeds into availability. So a service's resilience is its ability to absorb failure and to recover quickly from that failure. And you can see that a service that isn't resilient, that can't absorb failure, is clearly not going to be able to meet its availability requirements. And equally, if the service is able to absorb the failure but then takes a while to recover, it's going to drive down the availability. So we really want to make sure that we're optimizing for high resilience, quick recovery, and ability to absorb that failure in order to try and reach that nirvana of the 100% availability. Let's jump a little bit into some of the foundational building blocks that AWS delivers in order for us to build our services to make them highly resilient, and also in order for you to do the same. The first is the AWS region. So a region is a local geographic presence of AWS. We have 32 regions spread across the world, and we're continually adding to that list. And the thing with the region is that it uses a concept of a shared nothing architecture. Effectively, regions are entirely discrete, isolated installations of AWS. They're unaware of other regions. And this is really useful because it means that they are discrete, atomic, and they fail completely independently of each other. The other benefit that you get from an AWS region is it drives up your availability and resilience because it allows you to put your workload as close to where you need it. So, you can either put it close to your customers or close to where you're provisioning your workload, whatever works best for you. But it means that you can get that workload as close to where it's needed in order to make sure that you're reducing things like network hops, et cetera, which reduces the probability of network connectivity failure. Now, within the context of an AWS region, there are availability zones. Now, an availability zone is a logical abstraction over a physical infrastructure separation. What I mean by that is that every AWS region has 3 availability zones which logically partition the region into a set of physically discrete data centers. Any one availability zone comprises multiple data centers that are located geographically further away from the data centers that comprise another availability zone, such that in the event that there were a natural disaster of some sort, only one of those availability zones would be impacted. But close enough geographically that we can get very high throughput, low network between, so that it feels very local. So the benefit there is that you have this logical abstraction that you can build on top of, which is supported by independent infrastructure. And that independent infrastructure has independent power, independent networking, independent cooling. And so we can be assured that, in fact, availability zones will fail independently of each other. So now that we've gone through some of those basics, let's dive a little bit into the ECS architecture itself. But before I do that, I'm going to take a drink of water. It's a bit dry out here in Vegas. So let's dive a little bit into the ECS architecture and talk about how we use some of these concepts in ECS in order to deliver the availability that we need. So first off, ECS is installed in every AWS region, and it uses the shared nothing architecture. Effectively, ECS in one region is completely unaware of ECS in any other region. It is operated independently, functions independently. ECS is also present in at least 3 availability zones in every region that it's installed in. Now, up here you can see I'm talking about ECS in terms of the ECS control plane. So let me just describe a little bit what I mean by the ECS control plane. So the ECS control plane is that portion of the ECS managed service which does the provisioning of your workloads. So it's the thing that drives the scheduler, it's doing placement, it's doing deployments for you. So it's the management layer, it's the orchestrated management layer that we deliver to you. As I said, that ECS control plane is delivered in at least 3 availability zones. Now, one of the ways that we could provision that control plane is we could work out how much capacity we needed in order to serve the TPS rates that Maish was talking about earlier, and we could provision that capacity across these 3 availability zones. But what might happen, and so let's say, for example, we're provisioning at sort of the P100 of capacity that we need. What might happen, though, is that if one of those availability zones were to fail, we end up in a situation where, because we're deployed over the 3 in this particular case, we end up with only 66% of the capacity that we would need in order to serve the traffic that is required. And so as a result of that, we effectively end up in a situation where we need to scale up in response to this event. When you take that approach, you introduce a bimodality into your service. A bimodal behavior in a service is one where the service's standard operating procedure deviates to something different in the face of failure. So it's actually doing something different in the face of failure. And so we want to really try and avoid that. And so we try very hard to index on leveraging a principle that we call static stability. And so static stability means that you want to be in a position where your service is able to handle a failure of a dependency and doesn't need mutation of that service in order to continue to operate. So you want to be able to effectively be running in a steady state and remove this need for a bimodal behavior, to be able to take this corrective action. The way that we do that for ECS is that we pre-scale our ECS service to 150% of our P100 peak plus a percentage. That effectively means that at any point in time, ECS is over-provisioned in every region in order to make sure that in the event that an availability zone were to fail, ECS continues to operate at 100% of capacity. And that delivers the static stability, which is an incredibly important concept for us, and we leverage it extensively in terms of how we do operations. We're going to get into that more. So really key to this is this notion of over-provisioning, pre-scaling in order to make sure that we are able to handle this the eventuality of an availability zone failure, but then leaning heavily on the idea that availability zones fail independently of each other, and that ECS is entirely isolated within the region that it exists in. Now, you're actually able to take advantage of this in your implementations running on top of ECS. So ECS has I'm going to introduce 2 concepts to you. You probably are familiar with these. The first is the notion of an ECS service. An ECS service describes an application workload where it has an associated desire state and that desired count rather, and that desired count describes the number of ECS tasks, the number of workers that you need in order to deliver that service. So in this particular example, we have an ECS service which has a single ECS task, so a desired count of 1. ECS will actively make sure that it drives towards your desired count. So it will continually provision capacity to make sure that you are in a position where you have the desired count that you need. Now, obviously, in this particular implementation, we're sort of tempting fate. We're picking a fight with Mr. Murphy, as it were. Because in the event that one of these tasks, that this task were to fail, we would have a 100% outage. And so we want to avoid that. In a perfect world, what we want to do is pre-scale to make sure that we have presence in at least 3 availability zones, because that way we have this ability to be able to have a single failure and then have our workloads continue to operate in the other 2. So in this particular case, in this example, our ECS service is provisioned with 3 tasks, and those 3 tasks are spread across our 3 availability zones. Now, in this example, we're using ECS Fargate. Fargate is our serverless compute platform. And the thing with Fargate is that when you run an ECS service on top of Fargate, Fargate will automatically spread the placement of the tasks that you ask it to provision. So it will use the desired count, and it will use the availability zones that you tell it to provision into, and it will make sure that it continually spreads the load or those workloads across those availability zones. So that means that by default, ECS is giving you the ability to be able to provision capacity and to leverage these availability zones in the same way that we do in order to deliver the availability posture that we want. Now, you can do the same thing with ECS on EC2. As Maesh called out, ECS runs on multiple capacity types. You can do the same thing with ECS on EC2, although when you do that, you need to be a little bit more conscious of the fact that underlying the capacity is an EC2 instance that you own and manage. And so typically the way you would use that is with an auto-scaling group, more often than not with capacity providers and a managed auto-scaling group. And what you want to make sure of is that the auto-scaling group that you're using is provisioning EC2 instances into the availability zones that you're going to be leveraging for your task placement. So if you have at least 3 availability zones provisioned for your auto-scaling group, your EC2 instances will be provisioned also spread across those 3 availability zones. You then do the same configuration for your ECS service, and the end result is that you will get the same spread placement. So one of the things that I talked about earlier is the notion of pre-scale. We pre-scale our service to 150% of peak. And so you might be asking yourself, well, how do I get to work out what that number needs to be? What do I set my desired count to in order to find that number? So the way that we do this is we start with our base desired count. And in this particular case, as I said, the metric that we use is our peak, so our P100 of throughput plus some percentage above that. And then we work out how many availability zones we'll be using. So in the example that we've been using so far, we've been using 3 availability zones. And we want to use these 2 numbers in order to work out our target desired count. So in other words, our target capacity that we want to provision. And so this formula will give you that outcome. So for example, in a case where we had a service that needed 6 tasks active at all times in order to meet the throughput or the demand that it needed, and we were using 3 availability zones, well, you can see here what we would need is a desired count of 9 tasks. That gives us a 50% over-provisioning. Now, if we were in a position where our service was growing, let's say, for example, in this particular case, we've been very successful and we've gone from 6 to needing 600, well, there's benefit in actually incorporating more availability zones. Many of the AWS regions have more than 3 availability zones, and in those regions, leveraging more availability zones actually gets you the same availability profile, the same availability posture, but at a cheaper cost. So you can see here in this particular case, we've scaled up. We're 100 times more successful, which is fantastic, so we're doing very well. And as a result of that, we've also decided that we're going to incorporate 6 availability zones into our provisioning. And so here we actually end up with a 30% saving in terms of the utilization, but with the same availability posture, keeping in mind that availability zones fail independently of each other. And so at any point in time, we will always have 5 availability zones to serve the traffic that we need. So with that, I'm going to move on to a slightly different idea. So we talked a lot about static stability and how we can use availability zones and static stability to be pre-scaled in order to make sure that we can handle failure. Static stability is incredibly useful with availability zones because it gives us infrastructure isolation. But what about things like software deployments? How do we make sure, and sort of scale considerations, how do we get software isolation? So the way that we do this in ECS is that in every AWS region, ECS is actually delivered as partitions. And so a partition is a full copy of the ECS control plane running but multiple copies of it. And what we do is we run a routing proxy, a very thin routing layer, over the top of that partition, of those partitions, which allows us to route traffic into any one partition. And the reason that the partitions are so powerful is because it gives us an opportunity to be able to isolate work such that in the event that there were a software failure or a scaling failure of some sort, in a particular partition, the blast radius, the impact is mitigated by virtue of only impacting those workloads running in that particular partition. This is also incredibly useful for us in terms of scaling up and scaling out. You can imagine that in a service where we're provisioning 2.25 billion tasks a week, and we're serving tens of thousands of transactions a second, it can be very difficult to do scale testing in a non-production environment. It becomes very expensive. And so one of the ways that we do this is by partitioning the service and creating these full copies, full partitions of our service, we can scale test to breaking in a non-production environment a portion of the functionality of the control plane, or in fact a full copy of the control plane in that non-production environment, and we know how much capacity then one copy of the control plane can take. That gives us an opportunity to then to be able to work out how much capacity we need in any given region. So for example, if we know that a given partition can handle 100 requests, and we need 1,000 requests in a region, well, it means we know that we need at least 10 partitions in that region. The big benefit or a benefit that we get from this is, in fact, you can leverage this underlying partitioning through the ECS cluster. So the way that we do sharding, effectively the way that we do routing of the workloads onto these partitions, is using a combination of your AWS account ID and your cluster ID. That effectively means that when you create a workload and you create that inside a cluster, you're getting allocated a partition of the ECS control plane. And then were you to create another cluster, you will be allocated a separate partition for that control plane, etc. And so the benefit you get here is that you can work out how you want to isolate your workloads and use this partitioning mechanism, use clusters to create your own partitioning within your workloads. Now, in ECS, the ECS cluster defaults are very high. You can have thousands of clusters by default. There is no charge for ECS clusters. And as long as the clusters are provisioned onto the underlying VPC, the underlying network, there's no reason why your applications running each cluster can see each other and talk to each other, etc. So the cluster is really a namespace, but it does give you this opportunity to be able to isolate workloads across your clusters in order to benefit from this workload isolation that we have built in to ECS under the hood. So moving on from that, let's talk a little bit about how we operate the service for resilience. So we've covered two ideas, two design patterns that we use in order to think about how to design for failure, how to architect for failure. Now we're going to cover a little bit about how we think about operating for resilience. My clicker's not clicking. Yes, it is. Sorry. All right. So one of the things that you might see if you look back at the diagrams that we looked at is that we're creating sort of a mesh, right? So we've got these verticals, which are our infrastructure isolation through static stability for our availability zones, and that we've got these partitions, these cells, as we refer to them internally, these full copies of ECS in a given region. And so each of those full cells has delivered against that static stability promise. They are all pre-scaled to 150%. And so as a result, you end up with this mesh. That means that, in fact, we can deploy a change into one portion of that mesh and isolate that change quite usefully so that we can make sure that that if in the event that the change were impactful, it impacts a very small subset of workload. And the way that we do this is we use a strategy that we call rolling deployments. So for a rolling deployment, what we will do is we will deploy a change set to an availability zone and to a single availability zone in a single partition. The availability zone and partition, or the cell that we have, always comprises multiple workers, right? So ECS comprises many services. Each of those services is leveraging the same partitioning structure, the same architecture. And in any one of those cells, there will be multiple workers that are serving traffic for that particular partition in that particular availability zone. And so in this example that we have here, we have 18 of those workers that are serving it. And the way that we do rolling deployments is we will make sure first, obviously, that we've run regression testing, integration testing, and scale testing for the software. We want to make sure that we are very confident in the change, but we always view any change rolling out with some degree of trepidation and caution. So we encourage our engineers to view change with caution and to make sure that when we roll it out, we build confidence over time. And so the way that we do this with rolling deployments is that we will deploy the change to a very small subset of the set of servers, or the set of workers, in a cell in an availability zone. So in this particular case, we're rolling out to 3 of those workers first. As we build confidence, we will continue to roll out in steps of 3 until we've completely rolled out to 1 cell in 1 partition. Assuming that goes well and we're comfortable, we would then move on to the next availability zone, the next cell, and the next partition. And so on until we've eventually deployed that particular change set to all of the availability zones for that particular cell. Now, the benefit we have with this approach is, going back to that static stability that we were talking about earlier, is in the event that there were a failure, we're in a position where we can immediately weigh away, we can move traffic out of that availability zone because we assume that availability zones will fail. And so we've designed for that as part of our architecture, and as part of our normalization of operation of failure, we've designed that into the way that we do deployments as well. The way that we do this is we have automated monitors continually monitoring the way that the service has been continually monitoring any one partition and in any one availability zone as we do those deployments. And the reason that we want automation here is because we want to make sure that we respond to failure as fast as we possibly can. That goes back to our resilience goal. Remember that part of the idea of resilience is the ability of the service to survive failure, but also its ability to recover quickly. So in order to do this, what we're doing is we're introducing this automatic alarm, and then we introduce this idea of bake time. Now, bake time is not actually a time as much as it is a measure of confidence. So what we will do is we will have a set of metrics that are continually monitoring the health of the service at the granularity that we're deploying, and then we will have another set of metrics and an associated alarm which is monitoring the health of the service to make sure that we're continually meeting our customers' needs in terms of that availability. And what we will do is we will decide a threshold after which we've built sufficient confidence that we feel like the deployment can move on, and we call this bake time. Now, we're fortunate in that because we're serving tens of thousands of TPS a second, we could set a bake time of, I need to see 100,000 successful operations, and that will take in the order of 10 to 15 seconds to complete. And so we can get a very high confidence in the value of the offering the change that we've shipped in a very short period of time, just by virtue of measuring the success of that call volume. So So in the event that this alarm identified that in fact there was a failure, it will automatically trigger a rollback. In fact, it will do two things. It'll trigger a rollback, and then at the same time, we also have those alarms monitoring the availability zone health for that particular partition, and it will automatically weigh traffic away. And the benefit we get from this is it allows us to continuously deploy our service, which is incredibly useful for us. We're very privileged in that ECS is growing and popular. We have a lot of features that we are shipping, enhancements in terms of availability, improvements, and bug fixes, et cetera. And so we're deploying ECS multiple times a day. Like I said earlier, ECS comprises multiple services, and each of those services is continuously deployed. And so ECS is provisioning will be rolling out many times a day, and we want to be in a position where, in the event of failure, we automatically roll way away from that failure without impacting our customers, and we can do that safely and with confidence. Now, all of the conversation that we've had so far has talked about ECS delivery in the context of a single region. But like we said earlier, ECS is currently present in 32 regions, and as we grow AWS, it will be present in all of those. And so one of the things that we have to think about is how do we do this globally? How do we roll out globally? So we use a concept called pipelines, where what we will do is we will deploy into our pipelines always start we always assume that the change set that we're about to roll out is unhealthy. We always take a pessimistic view. And so the pipeline will make sure that it rolls out, like I said previously, to a single region, in a single partition, in a single availability zone. And as we build confidence with that change, we would then roll it out to the next set of partitions in that region, and potentially to the next set of regions. But importantly, we never apply a change into a region in more than one availability zone at a time. And that's to make sure that we go back to that static stability premise. We have to be in a position where at any point in time we can assume that an availability zone will fail or is failing, and so that we can weigh that traffic away. Now, as we build confidence, we will accelerate that deployment, but again, we never violate that principle, this idea of static stability, this idea that we never make change to more than one availability zone in a region at a time for the same change set. And so we will build that confidence over time, and as you can see, we will start to roll out to more and more partitions and more and more regions concurrently in order to accelerate that deployment. And this is ultimately what allows us to be able to deliver change relatively quickly through those pipelines. Now, importantly, we are continuously deploying and we are shipping change multiple times a day. And so at any point in time through those pipelines, we may well have multiple change sets. But again, just to double down, we never make more than one change in an availability zone at a time, and we never apply that change to more than one availability zone in the same region at a time. So given that, I'm going to hand back to Mahesh to talk about how we continuously improve our service.
Thank you very much, Malcolm. Yep, thanks, Malcolm. So we've been talking a lot about processes and tools. And I actually forgot to do something at the beginning of the session, so I'll do it now. There's a lot of things besides the process and tools, it's also the people. So I want to tell you a very short story about how this actual session came about. Every week on our team with product management and the principal engineers and the developer advocate team as well, we have a weekly meeting to go over our business metrics, to go over open bugs, how are we doing as a service, and also getting feedback from customers. And how we have to have that feedback, how we can act on it. And during one of these meetings a couple of months ago, there was a feedback, it was a request that one of our customers asked for a specific deep dive into how ACS works. And I asked during that meeting, is this a request that we get on a regular basis? So the answer was yes. And we don't have, up until now, real information of how this actually works in the background under the covers. So we took upon ourselves to actually create the content for this event, and there's also going to be a slightly more detailed blog post from what you've heard today coming out next week, so watch the AWS Containers blog for that article. And this is the content that we're sharing it today, because in in Amazon itself, we use mechanisms. Mechanisms are tools or processes that we use. We can scale the work that we do to not only one specific service team or one specific service or one organization. We use it to scale globally across the whole company. So now that the story's done, let's go into some of the aspects of the operational and processes that we use inside. On the screen is what we call a flywheel. A flywheel is a concept which I'm sure you might have seen before in some of our documentation. It's a circular motion which we continuously use, and every team and every organization and every service and anything within inside has their own version of the flywheel. This over here is the Uptime flywheel, which we usually use for chaos engineering experiments and continuous improvement. So I'll just walk you through the flywheel and how it starts. So on the top right-hand side, if you're looking at the screen, you have the first stage is the prepare stage. When you run some kind of chaos engineering experiment or game days in order to test your service, the most important thing you have to do is plan and prepare properly before you start running anything. What you're trying to do, what you expect to happen, what you need in the room, and how you're going to solve the problem. Because unleashing these kind of experiments and breaking things on purpose without having a solution which you're going to use and know how to solve the problem is the most dangerous thing you can ever do. So please never ever do that without running a prepare or a planning stage. Based on that plan and preparation, after the experiment starts running, you go into the detect phase. Did you have all the metrics that you expected to see? Were the logs flowing correctly? Did I get the right alerts that something was wrong with my system based on the change in the experiment that I ran? Did I have enough people in the room? Which goes into the response phase. Once you get if you have enough information to understand what is going on, you have to have the right people in order to fix it, or the right tools or processes. So were we able to respond in the amount of time which we thought we would do? Did we have the right people on the call? Did we have the right processes, the right scripts, the right automated actions or operations in order to resolve, for example, scaling up an instance or scaling up a cluster? All those things are the response phase which we hoped we had. And that's what we also have to test as part of our experiment. The last phase is the learn phase. We take all the actions and everything that we went through, and we continuously try to improve. Did everything we expect actually did happen, or were we surprised by something which we never ever thought about? Are the things we can understand from the experiment that we ran that we can improve the next time if we do another experiment or in a different server at a different scale in a different region, and improve continuously without having to make these things run into problems time after time after time. The whole concept of this flywheel is essentially to lead to shorter incidents and less incidents. Because, of course, as Malcolm says, and Werner Vogels and Murphy, something's going to break. No matter how much you plan for it, there's something you never thought of or never encountered before. Something will happen. But the more you practice these operations and these processes, the easier it will be for you to recover, the quicker it will be for you to recover, and the less downtime you will have for your customers. I want to dive into that learn phase a tiny bit, and one of the tools that we use internally in Amazon, which I think will be very beneficial. It's a correction of errors, a COE. A COE is a process which we use in order, as a part of that learning phase, of how to improve. It's a mechanism, as I said before, things which we use continuously to scale within our company. And it's a mechanism to identify problems which we encountered, add ownership to fix those problems if we need to be, if any, in certain cases. And of course, the most important thing is to share that knowledge with other teams and organizations, that it doesn't say compartmentalized and tribal knowledge, that people can learn from what we've encountered and experienced, and they might experience as well in their own services and products. And eventually, of course, the most important is to reduce the amount of incidents that we have. So the other thing is, it's not a blame game. In other words, we never use this process as to blame a specific team, tool, process, organization. This is something we use as a learning, positive process. And it's not a punishment for anybody else, because mistakes can happen. The question is, how do we prevent them from happening again worse down the road, and what processes and tools do we put into place in order for those things to not occur again? When do we use the COE? When we have customer impacting events. For example, if a service goes down, if a customer can't press the order button on Amazon.com, or they can't launch an ECS task because an API was down. So if there's a customer impacting event, we will run a COE on that event. If it was a procedural miss, for example, in our planning phase, we expected something to happen and something completely different went haywire. We didn't understand our system properly, or we don't have enough knowledge, so that means we have to run a COE to understand what we missed and how we're going to fix it. And of course, other incidents which can reveal some kind of opportunity for improvement amongst our teams, other teams, these are things which will use the COE document. So what does the COE look like? COE is divided into two parts with some bullet points. So the first part is the supporting information. Supporting information starts with the impact. What was the impact of the actual outage that we had, or the incident that we have? How many customers were affected? What was the exact thing that they couldn't do? We make very, very detailed timeline of what happened, when the incident started, when we detected that there was a problem. The shorter time for that to happen, the better it is for everybody. We have supporting metrics, logs, screenshots of the actual monitoring graphs, because a picture is better than 1,000 words, and you can actually see how your API response dropped from whatever it was, usually your P100 to something to P20 because of an outage. And we go through incident questions. What actually happened? How did we discover this incident? How could we have shortened the time to discover this incident? What were the actions we took in order to repair the problem or diagnose the problem and fix it eventually, so that our customers were finally back to where they were before we started? The second part of the COE is the corrections part. And here we have the 5 whys which we start. The 5 whys is a mechanism which we use internally of trying to actually get down to the root cause of what the problem was. Usually it's a configuration change, but that's not the root cause, because everything results usually with a configuration change, unless it's the act of God and something goes wrong. But diving deep into those questions and using the process of 5 whys, what actually was the reasoning of that configuration change, and why it wasn't checked, and why it wasn't validated, and why it wasn't deployed only in a small subset of the fleet. And we continuously dive further into these kind of questions in order to actually find what was the root cause of the problem, so that we can identify it and fix it. The second thing is the lessons learned, what we learned from this incident. We learned that we shouldn't push configuration changes in the middle of chaos experiments, or all kinds of things. Like, there are a number of different lessons that can be learned from these kind of events. And they're usually divided into 2 parts, and that is the short term and the long term. The short term is to make sure that we fix the most important and critical problems, that they don't happen again immediately. And there are things which are the long term, which we have to improve our processes in order to make sure that this doesn't happen again further down the road, either by us or by another team. And these things usually go into the service team's backlog and the roadmap in order to. This could be by decoupling services along the way, because we found out that there was some kind of weak point or critical part of the infrastructure which wasn't able to handle capacity, so we have to split the service into 2 different parts, and this will be a roadmap item which will go down. And these are things which are constantly managed with actions items with an owner from the service teams, to make sure that they're done and tracked on a regular basis on every single one of these documents. You'll see on the top that I left an open line, and that is a summary, because that's usually what you write last, based on all the information at the bottom. Small paragraph, executive summary of what was the problem, what we did, how we solved it, and what we learned, in a very short form, so that the people can also understand and get a good view of what's going to happen when they go through the details of the document. Let's recap of what we did today then. So we talked a little bit about how we build services for availability and resilience. We talked what the difference is between availability, how we measure it, how we look at it inside our organizations. Same thing with resilience, how we take steps, and we are, as we say, skeptical cautiousness. What was the word you used, Malcolm? For skeptical? Cautious skepticism, thank you very much. Cautious skepticism, how we really, really make sure that we deploy in a very, very measured and careful way to make sure that we don't have any impact on our customers and the service that they're using, and some of the continuous improvement processes which we use inside our organization, within Amazon as well. Most of what you've heard today has already been published as a white paper. We have something called the Amazon Builders Library, which is a set of very detailed white papers from our senior principal engineers and principal engineers, and Malcolm, of course, has also written a number of articles there as well, on how we design systems and look at systems at scale within Amazon. Yeah, it doesn't give you all the details of how we build every single thing, but it gives you the concepts and how the design principles which we use, like we did here in this talk. And a lot of the concepts which we used are available in these 6 different articles here, which you can read, white papers. If you're bored in the weekend reading, it will be a good thing to read on the plane if you would like. This is not the only ECS or Fargate session we have here at the event. Some of them might have already occurred, so I apologize that maybe you won't be able to catch all of them. But we have a number of different ECS and Fargate sessions here available at the event. If you want to catch the recordings, which are available afterwards, after the event, please do. Chalk talks, workshop sessions, builder sessions, these are things which I would advise you, if you have the time and passion for this technology, to definitely go and have a look at one of these sessions as well. The last thing I would like to point you to is the Modern Applications and Open Source Zone, which is located on the expo floor. There's a map kind of at the end when you're coming from the expo entrance. At the bottom is where the registration was. Behind the registration, you go walk all the way to the end to the right. You'll see a big Modern Application and Open Source Zone where we have engineers, product managers, people like me, the developer advocates kits, which are there to speak to you and answer your questions and listen to your feedback, because that's the most important to us, is the fact of the feedback that you give us. Based on that, we develop our services, improve our products, and make them as they are. Before you get up, please, I have a request. If you haven't already installed the application, I hope you have, for the event, please take it out and don't forget to fill in the survey. We would really, really, really appreciate your feedback on the session today. Any other thoughts and comments you would like to let us know, please share. Our emails here are up on the screen. Also Twitter accounts. If you want to send us, either of us, a message, please, you're more than welcome. And with that, if there are any questions, there are microphones, I think, on either side, if I can see properly. Yes, there are. Please feel free to come up to the mic and ask a question. There are stickers here that we have from ECS if you would like as well. And thank you very much for attending today.